The question is often asked, is a radial arm saw worth owning? Well, I think a radial arm saw is very much worth owning. In fact, I believe that a radial arm saw properly tuned, a quality radial arm saw properly tuned, is probably the best choice for a small shop that doesn't have enough room for a lot of tools. I think that it can replace, for a small shop, I think it can easily replace the radial arm saw. I'm sorry, the table saw. And that's what I plan on doing. I've got a small table saw, but I'm going to replace it with this here radial arm saw because I think that the radial arm saw is a better choice. But the first thing you have to have is a quality machine. By quality, I mean cast iron construction on the arms. No plastic on the top, no plastic on the ends. Solid cast iron construction. Good heavy. Now this will be aluminum. This end cap's aluminum, but good solid cast iron and aluminum construction. No plastic crap. You know, everything on this saw made in the 50s is either aluminum. Well, hell, you look it over, the only thing that's plastic is these knobs, and that's it. So you need a good, solid cast iron saw. Now, who makes those? As far as I know, all Delta saws are built this way. Most DeWalt's, pre-65 or 70, something like that, most of them are going to be solid cast iron construction, and a few of the early Craftsmen. If you don't start off with a good saw, with a quality cast iron saw that was quality built, you're never going to get the thing tuned up to cut the way you want it to cut. Okay, so that's number one. Number two, everything that is supposed to move has to move freely. So this has to move freely. You have to be able to make this adjustment freely. It has to move freely. All right? Oops, got a cord there. That's not helping things move freely. Just hook the lamp cord. Okay? Everything has to move freely. Okay? This when you want to turn to a 45, that has to move freely. When you want to crank this around to an outrip, it has to move easily and lock down tightly. There can't be any wiggling, moving around. Okay? You want those adjustments to move easily and smoothly. You want this to roll, the carriage to roll on the arm in those tracks, nice and smoothly. Okay, you want these bearings to move freely. All right? And everything that locks down must lock down tightly. When you want this arm to stay put, that has to lock down tightly. This has to lock down tightly. This has to lock down tightly. This clamp has to lock down tightly. Everything that locks down must lock down tightly. Number four, that table's got to be flat when you make it. It's got to be flat and straight before you install it on the radial arm saw. You can't expect to straighten that thing after you've installed it. I tried it. It don't work. It's got to be straight before. All right, and there's several different ways of making tables. Whichever method you choose, make sure you do it right. Make sure you get it flat and straight. And the closer it is when you build it, the less, if you have to, you're going to have to take a sander to the thing and sand at a 45-degree angle, both directions, until you finally get the thing flat. I mean, you've got to have a good straight edge. The edge of a piece of factory edge of a piece of 1/2-inch plywood, 3.5, 4 feet long, is straight. I bet you they're within 1,000th or less. So you need a good straight edge. The table has to be flat and straight. Flat this way, straight, right? All right, so that's number 4. Number 5, the front edge. Get this camera down there. The front edge of the table, along here, has to be straight, and the back edge has to be straight of the table, and the front and back must run parallel to each other, because you're going to use the front edge of this table for some procedures, and I'll do videos on that to show. That'll show you how you do that. So the table has to be flat, straight, and everything must be parallel. All right, the front and back edges. Number 6, these carriage bearings have to be adjusted to run in this track. Some tracks are inside. Oops, let me get the camera up. I'm sorry. And zoom in a little bit. Okay, there are carriage bearings right here. There's 2 here and 2 on the other side. These 2 on this side, on the right-hand side of the saw, are eccentrics. And so you can adjust those. And these bearings have to be, not only do they have to run freely, so you have to clean those up, soak them in brake fluid, whatever you have to do, and then get some fresh machine oil down in them, because they have to run extremely smoothly. This way where the bearings ride, that has to be free of sawdust, free of burrs, free of built-up grease. I clean them up a little bit with 4/0 steel wool. That's not going to take off any metal. It just takes off what little rust there might be, the grease and all that kind of crap. All right. Then these bearings have to be adjusted to where when you move this saw with pretty good thumb pressure, you can't stop that bearing from rolling. All right. Because if you can stop it, that means this saw, this bearing is not making full contact with this way, and the saw can tilt up and down as you're cutting through wood. So the carriage bearings must be adjusted properly. All right. Number 7. All right. This come on. There. They put pretty tight springs on these so that when you make your adjustments, everything will fall into shape. When you swing this arm around, I've got bolts here, here, and here. You place the saw over that bolt, over each bolt, and the distance between the blade and the top of the table must be the same in all 3 locations there and all 3 locations here. And if it is, and we're talking down to a thousandths of an inch or less. Okay, we're talking getting this thing as close as humanly possible. So if the table is flat to begin with, when you move it around, oops, I didn't have the camera right. In other words, this has to be the same distance here, 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 and here on those 3 bolts. And if you have the table flat and straight when you start, then this arm, wherever you swing this arm on this table, that blade is going to be the same distance from the table to the blade. At every point that you can possibly put, how did I get that stuck in there? At every place that you can possibly put that saw blade. Now here's another thing, when you lock these things down, give them a little jiggle and push down on those nuts. When you lock these saws down, after you've moved them, give it a little jiggle and push down on that knob before you lock the thing. And that way it'll lock down in the same place every time. I've already done a video on that. This blade must run square to the table. All right? The other thing, let me unplug this thing, because I'm going to have the guard off of it. It'd probably be safe enough to do it without that unplugging it, but I've never seen a switch fail. But, you know, a person could bump it. I just take the blade off the thing and don't take any chances. Alright, just took the guard off. Now the next thing that has to be is that there can't be any heel in this blade. Right? So that's the static test. Is to put a square on, get in the gullets, and slide that over against the fence and the table at the same time, angle it up like that, and the gap here and the gap here, there must not be any gap. Alright? This is a static test. Test it in a couple of different places because your blade is not perfect. It's near perfect. But, and if you're getting a good deal there with the framing square, you're probably pretty darn close to getting rid of the heel. And the heel would be, let's see if I can get that. Okay, yes. That would be, see there's about 1 degree of heel right, oop. There's, oop, come on. Boy, it's touchy. Okay, that would be a whole bunch of heel. I just spun this blade around this way. So when you pull that saw through there, it's going to make a curve a 1/4 inch wide or so when you come across there. It's not going to be making a curve the thickness of this blade. So what you're doing when you adjust the heel is make sure that first you've made sure that the blade is tracking square to the fence. Now you have to make sure that the blade is parallel to the arm, all right? And those adjustments are made right here, by the way. But we won't get into that today because, well, time. The blade has to be adjusted 90 degrees to the fence. I'm sorry, 90 degrees to the table, which is another adjustment you do, a static adjustment with a framing square. All right, that's just a static adjustment. You need to do dynamic adjustments on these too, which means that you need to adjust the saw after cutting actual wood and checking the results. You got to use the proper blade, and by proper blade I mean a lot of guys have experimented, and it's kind of boiled down to now don't get me wrong, there could be others, and there probably are, but generally speaking the guys are using the Freud LU83R on the smaller saws, and they're using the same blade. This is an 8-inch blade. They're using the same blade, 10-inch blades and 12-inch blades of the same exact design, the LU series, LU83 series, and the Freud blade. And the only way you can, not the Freud blade, the Forrest blade. This costs about $55. The Forrest blade costs about $110. Is the Forrest blade twice as good? Well, it gives better results. There's no doubt about that. And if your budget allows it, if my budget allowed it, I'd have a Forrest blade on here, but I can't afford it. So you have to have the proper blade. Now this saw is designed to take up to a 10-inch blade. This is a 10-amp saw. You're not going to run a 10-inch blade very well on a 10-amp saw. So usually guys will run 8-inch blades and occasionally put a 10-inch blade on when they got something thicker they want to cut. But normally they'll run an 8-inch blade on this 10-amp saw. So you've got to have the proper blade. That means that no more than 10-degree positive hook angle on the teeth, and it can be less. It can be down to 5-degree or even 0-degree hook angle, but it can't be more than 10-degree. The thing is going to buck and kick and raise the wood up off the table and give you fits. Your saw must have enough power to cut the thickness of material that you're going to cut and the species that you're going to cut. This 10-amp saw, to my way of thinking, is at the lower limit of what you could call a pretty much universally usable radial arm saw. More amps would be better. I've got a 17-amp DeWalt that I haven't fixed up yet, that I plan on fixing up, and on that I'll probably run a 10-inch blade rather than a 12-inch blade that it could run. So the last thing that I'll say is, well, not the last thing probably, but is that you need to download, these things are available on the internet, and you can download your user's manual. The day I bought this saw, I downloaded this user's manual. It's got blow-ups for the parts, the names of all the parts. Now you can't order most of these parts, but some of them you can. But at least you know how the saw goes together, and it gives you pretty detailed instructions on how to tune up your saw. There are other methods. Guys have learned a lot. This was written in 1962 or 61. Yeah, 61 I think. And over the last 50 years or so, guys have learned better ways of tuning up the saws than are in these books. But if in this pamphlet, in this user's manual, if you use this user's manual, you'll come up with a good saw. So, is a radial arm saw worth owning? Yeah. If you got the patience and the intelligence necessary to tune one up and make a proper usable tool out of it. If you expect you're just going to go to Craigslist, run out and buy a saw, bring it home and slap a piece of 3/4 inch particle board on the table, on the thing, and use it for a table and put a fence on it, and expect it to give you quality cuts, well, it's not going to happen. That's why so many of these guys on the internet say, I never use the thing for ripping, I never use it for fine cuts, all I do is use it for rough cross cutting. Well, hell, if you're just going to do that, hell, I just assume, why have a great big old machine like this sitting there? If you're just going to use rough cross cutting, use a skill saw, it's much faster. Yeah, for those guys that won't take the time to tune them up, and won't take the time to to keep them in adjustment, well then they're pretty much worthless. But for guys that care about their work, care about their tools, and will take the time, I don't think there's a better tool in the shop than the trusty old radial arm saw. As long as you buy a decent one. That's my opinion. And thank you for watching.